Right now on Amplified, how engineers can thrive with rapid change.
I've never seen a technology come in and transform so fast as AI has just done over the last 18 months. Engineers need to be prepared, and that's the way life is going to be, because what we were doing today in 5 years' time is going to be very different.
Hi there, my name is Dusty Rhodes and you're welcome to Amplified, the Engineers Journal podcast. The world is changing around us as the web, weather, wars and more are rapidly changing everything in our everyday lives. In engineering, it's the same. How do you keep up with AI, robots, 3D scanning and printing and more? We're about to meet a man who does this on a daily basis, and I think he will inspire us to embrace change and advance our careers. His company, Irish Manufacturing Research, or IMR, connects cutting-edge manufacturing technology and Irish industries, where they demystify, de-risk and deliver emerging engineering tech for manufacturers. I'm delighted to welcome the CEO of IMR, Barry Kennedy. How are you?
Hi, Dusty.
So listen, let me set the scene. How did you get into our wonderful world of engineering? What was that little spark in your formative years?
Yeah, well, it's quite funny, actually. When I was in college, I actually started out doing science before I ended up finding my life in the whole engineering world. And I had intended fully to do biology after first year, and they were looking for volunteers to do physics. And the head of the department came along and said, I think you'd be really good doing physics. Would you not think about doing that? So I ended up in the spur of a moment making a decision not to go down the biological route, but actually to go down the physics route. And so I did my initial years in Kevin Street before starting to work in Trinity College Dublin in their engineering department. From then on, I've been working in engineering since. I worked in the microelectronic and electrical engineering in Trinity College for 10 years, did a master's degree there as well while I worked. And then eventually, after running some courses for Intel came along and said, you need to be working with us here in the semiconductor industry. And so then I took up a whole variety of engineering roles in Intel and leadership roles before eventually, after 18 years, making the very tough decision to leave and to go and set up this not-for-profit with other companies to help them on what we saw as a digital transition.
So why do you think it is important that people keep up with technology? What's wrong with doing it the good old-fashioned way?
Well, at the moment in Ireland, if I look at the manufacturing base, 37% of our GDP is dependent on manufacturing. So the manufacturing area is really, really important. And if you look at a metric that's quoted around the world, productivity, Ireland actually ranks as number one. And so you'd say when you see that number that Ireland is the most productive country on the planet and 37% of our GDP, sure, we've done a great job. Why would we want to worry about doing anything else? We have it all sussed. But when we look out there across the world and see what's happening, if I looked at somewhere like, let's say, Korea, for instance, and I look at the adoption rate of technologies that they're going with now, they have about 1,012 or so robots per 10,000 employees in their country. If you look at Germany, it's about 454. The UK is about 111, and Ireland is 55 robots per 10,000 employees. So just looking at that number alone in terms of automation, these countries are way ahead of where Ireland is today. And when you look at Ireland in terms of our digital competitiveness, we're 23rd in the world. And that's on a backdrop of us being the 9th most expensive country from a salary point of view in the world. So manufacturing, 37% of our country depends on it. We're the 9th most expensive in the world, and we're not at the races when it comes to automation. That just doesn't equate. And so we as a country and manufacturing in particular, if we're going to survive and thrive over the next number of years, we're going to have to adopt these new technologies so that it'll drive efficiencies in our manufacturing organizations and keep ourselves profitable, or we're going to be left behind.
So if we don't connect with new technologies, we're just not going to be efficient. And if we're not efficient, we're going to be too expensive. And then people will just go elsewhere.
That's it. It's simple as that.
That's why it's important. Okay, great. So listen, tell me then, what are you doing with IMR? Because IMR is very much a cutting edge manufacturing technology, and that's where you are, right? You try to demystify, de-risk and deliver, as I said in the intro. Tell me more about IMR.
So, IMR formed as a company over 10 years ago, although the cluster and community were together for about 15 years under a different heading. And so we approached the government when we formed, and Enterprise Ireland in particular, and Enterprise Ireland then agreed to fund us in the first mad phase of this. They didn't know what we were up to. We were a bit unusual because we were setting up as a not-for-profit. We were the first time this type of research centre was set up outside the universities. And we did that deliberately because what we wanted to do was to do what we call late stage research. Not the research that's done in the universities, which is a little bit more earlier and it's kind of speculative. We wanted to do research where companies were coming and saying, hey, I have a major problem in this area. Can you help me? And so it's late stage. And what we wanted to do was to be able to work with all the different universities and not be kind of locked into one and pull the goodness that they're doing there to come out and to help us solve those really meaningful challenges that we're trying to address within our manufacturing world.
So somebody comes to you with a problem and you go looking for a new modern solution for that problem, which is often coming from a university. So you then kind of have to commercialize it.
Correct. Yeah. So we act as that kind of interface, and we're the first time in the country that we've had this, because that's what engineers do. We take things, we modify them, we make them work in different settings. So I pull together what I like to think is the A-team of engineers to come along and to take all that good stuff and convert it into real meaningful solutions.
Can I ask you then about a couple of specific examples then of things that you've done? I know that somebody came to you and said that they wanted to measure the wing of aircrafts, and it had to be done, like anything in the aviation industry is down to millimeters or even smaller units of measurement. Can you tell me about that?
Sure. We were working with Airbus. And Airbus had a particular challenge where they wanted to get an inspection system so they can inspect the wings of the planes to make sure there's no damage done from flying. And the way it was normally done, somebody would come in on a cherry picker and we would inspect the wing to make sure everything was A-OK. And so we worked as part of this European program with other partners in Europe and in Ireland, to develop a scanning system that would inspect the wing and would be able to spot where any damages may have taken place. If there was a rivet, for instance, that had been a little bit damaged, it would be able to spot that and identify its location. And the clever thing about, the solution that the engineering team developed in IMR and with our partners was that the robot, we got a robot and a vision system, but that the robot had a inbuilt some form of AI in it, and it could learn, first of all, and it would know where it was on the wing at any point in time. Because normally with a robotic system in the old days, let's say, it's all beginning to change now, a robot needed to know where it was. It needed to have what's called a 0-0 reference point, the 0 point, and then geometrically it would be able to position itself and know where it needed to go. But that's kind of tricky if you're trying to bring in a very big plane into a hangar and it's got to stop exactly at that set point so that the robot would know where it is. That was going to make things a little bit harder. So the system that the team built, you can wheel this robot in on a trolley in essence, and it know where it was instantly on the wing, and we can do the scanning and to spot the faults. And we did that with a partner, a company called TEG there in Mullingar. And as part of that, they got a significant sum of money from the European Union as well to help them and to get involved in doing R&D programs. And they did some fantastic work down there. And as a result of that, they now have become what's called a tier 2 supplier into Airbus. That means they can directly sell their products into Airbus. And from a business enablement point of view, this is really important. And that's the kind, if I looked at kind of our Nirvana project in the work that we do within IMR, that was it, where we're solving a technical challenge and we're enabling business growth at the same time.
It's clear from chatting to you that robots are a very important part of what you do and the technology that you deal with. Now, when I think of robots, I think of the movies and iRobot and Will Smith and all that kind of stuff. When you think of robots, how do you describe them to people in an engineering sense?
I would see them as kind of, in my own simple mind, a mechanical aid to help you do things more efficiently and effectively. Okay? But in our world, the robot would be more typically an arm, which has got, a number of elbow joints and things on it, and a thing called an end effector on the end of it, which is like a gripping system for grabbing something and doing something with it. And our primary focus is in our research and development that we're working on today is focusing on what we call collaborative robotics. So it's robots that can work side by side a human being. And the reason why we're doing that and why we think that's important in this country is because we don't do a lot of the heavy engineering, automotive, aviation type engineering that exists in, say, Germany, where they'd be more inclined to use very large robots that sit in behind cages. In our case, we've got medical device companies. And so typically, the kind of component parts that we make are much smaller. Or we've got the food industry where we're processing food and things like that. So in that environment, the robots don't think to be as big. In general, the payloads, the weights that they're carrying isn't as heavy. And so we are looking for ways, can we get these robots to be able to work side by side a human being in a safe way? And can they be a lot more dexterous, if you like, for doing very fine tasks? Like, for instance, if you were trying to do a stent assembly in a med device company and you're trying to push two tiny tubes, one inside the other, that can only really be done today effectively with a human. It's very hard to get a robotic system to be able to do that. So we're working with robotic systems called haptic robots, for instance, and that means that it can feel. So an example of it, as if you ever decided you'd like to come down to our facility, we could show you there sometime, Dusty, or if any of your engineering teams that are listening here today would be interested in doing it, I tell them to please reach out. But if we've got a joystick system down there that moves a robot, and if the robot rubs on a slippy surface, you'll slide with it, and if it goes across a rough surface, you'll feel that vibration coming back up through the joystick system. And so it's using that type of haptic robotics to be able to determine if, for instance, you're trying to put one tube inside the other, if there's a bit of resistance there, and so that the robot then can make a slight adjustment to be able to insert one into the other a little bit better. So these type of robotic feedback systems are important with robots. We've got advanced vision systems now wrapped around those as well that look and see what's going on to make sure that that the robot isn't heading towards your hand, for instance, as it's moving in a certain work area. And that the robot will learn to move around you. And so we apply AI in the back end for these robotic systems to be able to learn from what they see happening in the environment. So for instance, if I walk into an area where the robot's working and I am right-handed and I'm moving my right hand in around to grab something, the robot says, oh, hang on a second, Barry's right-handed, And then if Dusty comes in and he's left-handed and he starts to put his hand and he's just swinging it from the other direction, the robot says, oh, hang on a second, Dusty's left-handed, I need to move my robotic arm around in a different direction. So that's what we're doing. We're working with robots with, that are haptic, that are small, that can work side by side a human being, that have AI sitting on the back of them, that they can self-learn, and looking at ways that this technology can be delivered and dropped into manufacturing environments safely so that human beings can work side by side and without getting injured.
Can you give me an example of something like that you're doing right now?
Oh gosh, there's so many projects we have going on at the moment. I'll give you just an interesting one that we did for the company there in the Midlands recently, which actually just shows the advantage of kind of robotic systems. They came to us and they had, say, a certain size of cardboard box which their product needs to go out in, but all their product goes out in the same size box. But in every box and in every order, there's a different mix in the box, right? And so if we say, for argument's sake, if you can imagine, say, nuts and bolts in a small plastic bag, like a money bag that you would have had years ago, right, for coins. And you have a certain number of nuts and a certain number of bolts and a certain number of washers. And then, depending on the order, sometimes the bolts are longer or shorter, as the case may be, or there'll be a larger number of bolts or a smaller number of bolts, as the case may be. So the orders can be all different. Well, the way this factory were operating, they were trying to put the nuts and bolts into the bag, or into the box, should I say, shake down the box, try and get it nice and flat so they could tape it, because you have to stack all these cardboard boxes one on top of the other. So that was a job that was driving them mad. And so they came to us and they said, look, we really would like to try and get rid of this problem, and can you fix it for us? So we put these bags, if you like, all dropping onto a conveyor belt, and they'd be moving along nice and slowly. And we set up a collaborative robot that would come along with a vision system on it and would pick up the various bolts and washers and put them into the cardboard box. But every time you would drop a bag like that into the box, it would take a different shape, because it's a plastic bag, and you drop it in, it gets all the different types of shapes. So using an AI algorithm and a vision system, we were able to look inside this box, and we were able to see what was happening at every time you dropped the bag into the box. And then we were able to make a recalculation, or the robotic system would make a recalculation, so that when we picked up the next bag, it would position it differently into the box. And then using other little tricks that we had there, a shaker deck and a few other bits and pieces, we were able to set up an automated system that meant that the employee didn't have to sit there putting all these things into this box and banging it down and trying to tape it. And so there was an example of us introducing a technology to solve a problem for a manufacturing firm.
Just thinking about kind of past projects and everything that you've worked on, what would you say was your own personal most challenging project?
Yeah, I remember, well, certainly in my days in Intel, I had some very challenging technical problems to go there because, they have, from a couple of million to a couple of billion transistors sitting on the size of your thumbnail in these microprocessors today. And in essence, you need 3 small little electrical connections to move to every single transistor. So you can imagine, the difficulty doing that. And as I often said to people, when you're making a microprocessor, how many of those millions and billions of transistors need to work for your microprocessor inside your computer to work? And people will be guessing, about 50, 60, 70. I said it's 100%. So they all have to work. So as the integration manager as I was at that point in time, I remember having some incredibly complex problems to try and solve, where we were doing electrical testing at the end of line that indicated there was something going wrong inside in the factory. But we have, you could have 200 or 300 process steps, and you could have at any process step maybe 10 or 15 different machines processing those processing steps. And you have problems going on in the middle of this line, and you've got to go and figure out, oh my God, where's this problem coming from? And so they were, there has been times in the past where I would have spent 3 or 4 weeks sitting in a room, a war room we used to call it, trying to isolate where this subtle problem was happening. And, the problem could be from something as simple as tiny dust particles, tinier and smaller than the width and the dimension of the human hair, if you can imagine dust that small, and maybe just a couple of dust particles, 1 or 2 dust particles, that's all, coming from some machine somewhere in there was causing that problem, and we had to isolate it and find that machine, because that was the difference between us getting 100% of those microprocessors working and not. And so, yeah, that really, I tell you, in terms of problem solving and being, I don't know, Inspector Morse or whatever, just getting down there and trying to detect where these problems were. They were very challenging. Great times, really enjoyed it. But from an engineering point of view, yeah, that tested me to the ability of my engineering capability, that's for sure.
Do you have kind of like a thought process that you go through? And I'm generally just kind of speaking like, this enormous problem where you're being handed a piece of electronics that is only a couple of millimeters wide. It's got billions of connections in it, and there's one spot of dust that is mucking it all up. That's an impossible problem. Do you have a thought process where you kind of go, okay, I'm going to go off into a dark room and think about it, then talk to other people, and then I'm going to try this? What do you do?
Yeah, no, we had, and that was the great thing about working in a company like Intel. They give you phenomenal training, and so I was taught and trained how to approach these complex problems, and so we'd have lots of different methodologies for doing it. But one of the more basic and obvious ones was called 7-step problem solving, where you first of all you contain the problem. If there's an issue going on here, try to isolate where the problem is. There's another capability called trees, which is the theory of inventive problem solving. And again, for highly complex, tricky engineering problems to solve, this methodology was really good at being able to do it. I can tell you, a story about, of how trees works. But
no, go on.
They brought a group of engineers into a school in the US, and to try and resolve this problem, where actually the females and the girls in the school in the bathrooms had gotten this. It became a trend with their lipstick, drawing lipstick on the mirrored glass in the bathrooms, and they wanted to fix this problem because the janitor who was cleaning the mirrors was finding it very difficult to get this very waxy solution off the glass. And so they bought the engineering team and said, we need to fix this problem. This stuff is very hard to get off. How are we going to solve it? And so all the engineers got together in a room and they started to brainstorm how they were going to do it. And they came up with all kinds of stuff about putting a film onto the glass that would make it easy for the wax to kind of come off, or make it hard for the wax to go on. And so they come up with that. They spent half a day coming up with those ideas. They were brought back into the bathroom again, and they were told, okay, now we want you to fix the problem, but you're only allowed to fix the problem from items that are here in the 4 walls of this bathroom. So suddenly, they changed the parameters on how they were to solve and fix this issue. And the engineers fixed the problem. But it was interesting the way they fixed it, because what they did was they got the janitor and a group of the girls from all the different classes to come in to see what it took him to fix this particular problem. So they asked him to go fix the problem. So in my mind, I thought that was they they feel sorry for him and understand how difficult it was, and they might stop. But they realised that that wouldn't be good enough because some people just, that wouldn't matter to them, right? So they said, okay, will you go show us how you clean the mirror? So he picked up the toilet brush and he dipped it into the toilet and he walked out to the mirror and he just rubbed it on the mirror like this. And instantly, the problem was fixed because word went across the school, don't do that. Now, of course, he didn't clean it that way, but it just planted that mental image in their mind. But I just thought, wow, talk about a way to solve a problem by thinking laterally, And so trees, anyway, back to trees itself, it is this methodology, it gets you to think differently by challenging you in slightly different ways, like I just mentioned there. And so, there's loads of examples of that where we've worked on trees to try and help us resolve some of those difficult challenges that we would have had in Intel and also in IMR,
And kind of when you play with things like that, it leads you down to discovering new things and changing the ways that you do things. When you approach it as a game, if you like.
Yeah.
Like the engineers in the bathroom and being told, and then all of a sudden it's like an escape room kind of a thing,
Yeah, you said it. It's about, in fact, a good word to use, gamification of it. You're absolutely right. Give people a challenge and excite them by the challenge is the best way to help resolve problems like this. And this is something we worked very hard within IMR when we formed it. We wanted to create a challenging, positive environment for the employees and the engineers that work there. Because I recognized years ago, if you put pressure on the human being and put them under extraordinary pressure to deliver and execute, they'll execute and deliver, but they won't think. They get into a kind of an auto mode and executing the task. If you want them to come up with creative ideas and solutions, they've got to be relaxed, And Einstein used to say, the best time for him to come up with his ideas when he was relaxing, having a bath. So we tried to create that environment. And so where you can challenge people in a fun way, where you say, okay, let's give this a go. Let's come up with some creative ways to approach it. And you get better ideas coming from people. So we would have, when we're trying to solve problems like that, we have brainstorming ideas, and where every idea is accepted as a good idea, even though some of them could be daft ideas. And it's funny. Often I found over the years, the daft idea, although in itself might have not been the right solution, but it was the seeding that brought us down a certain path to come up with a really good idea. It gets you to think slightly differently and look differently at the problem. But it was very important, it is very important that you're doing that in a way that people are kind of excited and challenged, in a kind of almost a fun way, versus feeling under pressure and being shouted at to get it fixed. It just doesn't work.
So do you think then that is a challenge for engineers who might be listening to the podcast now? I mean, it sounds great. And we've seen all these pictures of Google and the big technology companies, like you go to work and you're playing snooker, but you do need that time to play and to think and to stuff like that. But if you're in a job where it's like, boom, 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 I need boom, boom, boom. How do you, for yourself as an engineer, get that sense of play and wonderment and gamification back again?
So I think the way we work today is slightly different, and we find an awful lot of engineers manage to get a day or two at home a week, maybe 3 days in the office is kind of a thing that's kind of typically happening we see nowadays. And I think on that one day, there's opportunity for engineers to get some of the heady load of emails all done and out of the way, but then if they're trying to struggle and sorting out some a technical challenge, that they get a bit of reflective time to think about it. And I can just speak for myself as, running this operation in IMR. I value the days where I get at home and I'm thinking strategy and what we need to be doing. I get just space. I'm in my own zone and I don't have somebody knocking at the door saying, could I just disturb you for a minute? So I can really get some momentum going on things. So I think that can help. But it is important for companies and senior leadership there to ensure that they're creating enough space for their engineering teams to be able to think about how to solve the problems. And if you don't create that space for them, you're going to struggle and you'll band-aid solutions, as opposed to fixing solutions. And I have seen that in a lot of companies over the years where they haven't resolved problems. They've band-aided them and lived with them. They've tape around the leaking oil pipe instead of, disconnecting it and redesigning the part. So, but it is important and it needs to be done. Yeah, if you want to get good engineering ideas there to solve problems, you've got to create that space.
The world is changing always, and it just seems to be changing at a faster pace at the moment. Where do you think the skills gap is at the moment for engineers in the market?
I've asked this question twice recently, and I was at a talk there in Galway where the person who was speaking was talking about AI, and I was struck by an engineer from a software coder, should I say, from a large multinational, walked up and he said, "With AI, my job as a software coder is now gone. Where should I go? Where should my career be?" And he was probably in his late 30s, let's say early 40s. And he was quite stressed by it. And he was a person who said, "I'm out of work now, so what do I do?" The fact of the matter is that some of the old traditional forms of engineering are still important, but we may not need as many people as we did in the past. But having those people available and understanding the principles, the fundamental principles, is critically important. If you look at the emerging ones, the whole area of advanced robotics, and now in particular AI, is the next wave, right? And so I would see, within the colleges over the next few years, that there'll probably be a less of an emphasis on the software coding side of things here, but more of an emphasis on AI and AI tools, and how engineers need to be able to work with and utilize these new tools. And I call AI a tool to drive improvements. Anyone who's in the kind of education side of it, and we do a lot of training courses like that, we're looking at it very carefully at the moment. But if you ask me, 3 years ago, I'd have been talking, doing a little bit of AI. Now today, it's kind of, oh my God, this thing, I'd never seen a technology come in and transform so fast as AI has just done over the last 18 months. I'll give you another example. Industrial 3D printing. That whole game is now being transformed, and there are large-scale industrial 3D printers that can print full component parts that go inside jet engines today. And so it's been transformative. And I was working with a company there recently, a medical device company who builds prosthetics, and they have an old traditional way of doing it. And they have craft people who would put plaster Paris around the point where the person's lost their limb. And they will, from that plaster of Paris, they'd make a mold, and from that they'll make the prosthetic to go over so that the person will be able to walk again, for instance, if they lost their leg. And we went down and spoke to them about this idea of industrial 3D printing. And they said, "Well, look, thank you, but we've been doing this for 40 years, and this is the way the business has gone." And we said, "Yeah, but we could do this with you just to show you what's coming, and we think it's important." So they agreed, and we worked with a Galway farmer who'd lost his leg. And we brought down a scanner and we scanned the joint, and then we, using an industrial 3D printer, printed out the prosthetic for that person. And that person put that prosthetic on, and it fit first time. Now, normally with the traditional way, it could take 3 or 4 times to do it, because when you put plaster of Paris around the joint and then you take it off, the plaster of Paris, because it's water-based, will shrink, and then you have to be able to make a judgment call. Hence the reason why I say, craft-based people who are able to make judgment calls around this thing here. It was a difficult thing to do to make a prosthetic. But the CEO looked at that and said, "Oh my God, this thing could absolutely wipe me. Do you know this new technology?" And so we said, yes, or you create a whole new world, of opportunity. So we went on a journey with that company, and we helped them upskill and train some of their employees to show them how you use the technology. And they were able to take the goodness and all the expertise that they had from the old way of doing businesses and apply it, if you like, into a digital world, so that they could now offer this as a service. So they do both today as a company. But when we were talking to them about that, I was explaining to them, in the dental industry, when it came to dental implants, it took 18 months globally for 80% of the market to flip into 3D printing. So it's fast. These technologies are coming at such a rate of knots. It's fast. And so engineers need to be prepared now to have lifelong learning. And that's the way life is going to be, because what we were doing today in 5 years' time is going to be very different, most likely. And so we have to be continuously learning, continuously looking at all these new technologies, and continuously thinking of ways how we can adopt them and introduce them into our work. And I'd have to say, engineers, broadly speaking, we're good at doing that. But if I looked at these technologies, the two that are, exciting me most at the moment will be what's going on in AI and how that can be applied certainly into the manufacturing world. And similarly, what I'm seeing happening with industrial 3D printing is phenomenal. And I think the one that has the single biggest opportunity and need for us as engineers is the whole area of the environment and climate change, and how we can create products that are carbon neutral. Let's throw that challenge on the table to engineers and say, okay, go solve that. So how can we make the things we need to have today without causing damage to the planet? That's a challenge in its own right. And so, it's no longer good enough for us as engineers to take raw materials out of the ground, purify it, design products, make products, use it, and then dump it back into the ground again. We've got to become much more circular in nature. And at every stage along the manufacturing process, engineers need to be involved in figuring out, if I'm going to make it, then how do I dismantle it when it's finished use so that I can reuse all the component parts again? That's key and important. And so I would say in the next 5 years, I think you're going to see an awful lot more jobs being created in that space for engineers.
Barry, your work has been recognised as an exceptional contribution to engineering through the Fellow of Engineers Ireland Award, so congratulations to you. Can I ask you, how do you keep fresh and coming up with ideas as your career progresses?
I tell you, I feed off other people. That's a terrible thing to say, right? But that's where I get personally my energy. I look at the research centre that we have built today. There's a phenomenal team of people that have made this happen. And I get energy from them, I think, human beings, we're kind of pack animals and we work well together. And hence the reason why, even when I'm talking about remote working with my own employees, I'm trying to encourage them, not mandating it, but trying to encourage them to come into the office, a few times a week, because you get energy from other people and you learn and see good ideas. But I think today, at this stage of my career, I really feed off looking at the enthusiasm of those young engineers coming in, trying to solve all these highly technical problems that exist for manufacturing firms, and doing things with robotic systems and AI and industrial 3D printing, or trying to solve the whole issue of the carbon footprint in manufacturing. And the ideation that they're coming up with, I just find that inspirational, and that's what puts a smile on my face when I go into work every day. Yesterday I was speaking to one of our senior team, and he was going through, I suppose, a bit of a crisis of thought in terms of what direction he wanted to go in his own career. And I just enjoyed that chat with him for the hour and a bit, as he's trying to grapple with his own career and where he's trying to go with it, and hopefully it helps. But yeah, that's where I get my energy from, is working with people like that, seeing what they're doing, and then trying to help them be the best that they can be.
Absolutely. I couldn't agree with you more. In that situation where you're giving advice to an engineer and career and stuff like that, generally, what kind of advice do you give? I mean, for people listening today who are looking towards the future, what would you say to them?
Well, the first thing I tell people, actually, and this is going to be, like probably sometimes somebody might say to you, that's really against yourselves as an organisation, because I've lost people, very good people in my organisation, based on the conversation that I've had with them. And I've told them, life is way too short, and to be in a job that you're unhappy with. And I said, the single most important thing to do in life is to figure out what drives happiness for yourself, and where do you get the most satisfaction. So as an engineer, you need to look at that and not be afraid to make the change if that's what is the right thing for you to do. But I was lucky enough to have spent some time with Maureen Gaffney. You might know Maureen Gaffney. She's a psychologist there, fantastic person. But she was talking about human beings and what makes human beings happy. And she said, it's very important that you find projects that are bigger than yourself. And so for engineers, I'd say the same thing. Look for that challenge that's bigger than yourself. In other words, like if I looked at my own team who are working in the circular economy, it's about they're driving forward to do something for the planet in a really important area. Or if I looked at the team in the medical, working in the industrial 3D printing, it's about finding solutions that make it easier for people who have lost a limb, for instance, and developing prosthetics and things like that for them. Or if I'm looking at in the world of the robotics and the digitization, where we're sensorizing systems and machines and doing all kinds of things like that, it's looking for ways to maybe take people out of dangerous environments, or so that robots can do the job in their place, or making their job a lot easier. It's about finding those projects. It could be also working with a basketball team and helping some young kids, do better in life. Or it could be looking after a sick child. It could be all those things here. But if I looked at it in the context of a professional way, I'd be always trying to encourage our engineers to find that project that's bigger than yourself, that's motivating you. So when you're getting up on Monday morning to go to work, that you're doing something that makes a difference.
That's a great point to end on. If you'd like to find out more about Barry Kennedy and some of the topics that we spoke about today, or indeed if you want to reach out and maybe take a visit down to IMR and visit Barry in person, you'll find notes and link details in the description area of this podcast. But for now, Barry Kennedy, CEO at IMR, thank you so much.
Thank you, Dustin.
If you enjoyed our podcast today, please do share with a friend in the business. Just tell them to search for Engineers Ireland in their podcast player. The podcast is produced by justpod.io for Engineers Ireland. For advanced episodes, more information on engineering across Ireland or career development opportunities, there are libraries of information on the website at engineersireland.ie. Until next time, from myself, Dusty Rhodes, thank you for listening.